All right, let's talk about Sentry. If you're a developer, you know this feeling, right? You open up Sentry and it's just a wall of alerts. It's this constant stream of noise that makes finding the real bugs feel like looking for a needle in a haystack. Well, today, we're going to fix that. We're going to tame Sentry's issue grouping so you can finally silence the noise and get back to fixing the bugs that actually matter. So you log in and you see this. 500 new issues. Your heart just kind of sinks, doesn't it? It feels like the whole application is on fire. This, my friends, is alert fatigue. It's when the sheer number of notifications just makes you want to close the tab and pretend you never saw it. But hang on a second. Here's the most important question you can ask. Are those 500 issues really 500 unique bugs? Or are they just 500 slightly different symptoms of the same, say, 3 or 4 underlying problems? Figuring that out is the absolute key to getting your sanity back.
Yeah, this feeling of just drowning in alerts, it's more than just annoying. It absolutely crushes productivity. Because when every notification feels like a false alarm, you start to tune them out. And that is exactly when a really critical bug can slip right past you. So to stop drowning, we first need to get inside Sentry's head and understand how it thinks.
And it really all comes down to 2 simple words: event and issue. Think of an event as a single snapshot. It's the raw data from one specific error that happened at one moment in time. But an issue is what we actually care about. It's a smart folder, a collection of all the similar events that Sentry thinks point to the same root cause. Sentry's whole job is to turn thousands of these individual events into a clean, short list of actionable issues.
So, how does Sentry do it? How does it decide which events belong together? Well, it's not magic. It's an algorithm, a step-by-step process that follows a strict order of operations to create what's called a fingerprint for every single event. If 2 events get the same fingerprint, boom, they get grouped into the same issue.
And here's that order of operations. Sentry has a clear hierarchy. It always tries to use the best, most reliable information it has first. So number 1, it looks for a custom fingerprint that you might have set up. If that's not there, it'll try to use the stack trace. No stack trace? Okay, it falls back to the exception data. And if all else fails, its last resort is to just look at the raw error message itself.
And this table right here, it shows you why that order is so important. It's all about reliability. A custom fingerprint, that's you telling Sentry exactly what to do, so it's absolute. A stack trace is super reliable because it points to the exact lines of code that broke. But as we go down that list, things get shaky. The error message is the least reliable because it often has dynamic stuff in it, like user IDs or timestamps that change every single time.
And when Sentry is forced to rely on that shaky data, things go wrong in 2 classic ways. First, you get undergrouping, which is just way too many issues. This is what happens when those dynamic error messages with unique IDs make Sentry think every error is a brand new bug. But on the flip side, you can get overgrouping, where totally different bugs get smashed together because they share a generic stack trace, maybe from a central API gateway or something. So what do? We have to take back control from the default algorithm when it gets confused. And our number 1 most powerful tool to do this is a custom fingerprint rule. These are rules you set up right in your Sentry project settings to override that default logic and tell Sentry exactly how you want things grouped.
And the best part? The syntax is so simple. Seriously, this is it. On the left, you have a matcher that looks for certain patterns in an error. And on the right, you have the fingerprint, just a simple piece of text that you want to assign if it finds a match. That's it. Match this, group it like that. Let's make this real. Imagine your database keeps timing out and throwing a connection error. With this one little rule, we're telling Sentry, hey, anytime you see an error and its type is connection error, I don't care about anything else. Just group it into one single issue called database timeout. And just like that, dozens of noisy, annoying errors become one clean, actionable ticket. Okay, but what if you don't want to completely throw out Sentry's logic? Maybe you just want to tweak it a bit. Well, that's what the default variable is for. It's like a magic placeholder. It tells Sentry, go ahead and create your normal fingerprint, but let me just add a little extra information to it. This lets you refine groups instead of totally replacing them.
And this is just the beginning. You have this whole toolkit of variables you can use. You can pull in the error type, the transaction name, a specific function from the stack trace, you name it. This gives you this incredibly fine-grained control to build the perfect grouping logic for your app.
So once you've mastered fingerprinting, there's another level of customization we can unlock. We can actually influence the grouping by telling Sentry what parts of a stack trace are actually our code and what parts are just noise from other libraries.
See, Sentry's grouping algorithm gives special treatment to what it calls in-app frames. These are the pieces of the stack trace that belong to your application, the code you actually wrote, not the code from third-party frameworks or libraries. Getting this classification right is absolutely critical for making sure Sentry focuses on the right things. And a rule like this is how you do it. For a JavaScript project, this one line is a game changer. It tells Sentry that any code path that includes node modules is not part of our application. The -app flag marks it as external, and, crucially, the -group flag tells Sentry to completely ignore it when it's calculating that fingerprint. This is how you force Sentry to focus on the signal from your code, not the noise from your dependencies. Now look, sometimes you just need to clean things up quickly, and Sentry does let you manually merge issues together. But let's be super clear, this is a band-aid. The real win, the real payoff, comes from writing smart rules that fix the problem for good. When you manually merge two issues, all you're doing is tidying up your inbox for today. Sentry doesn't learn from this. It doesn't create a new rule for you. So the next time those errors come in, they're just going to create separate issues all over again. Manual merging is for housekeeping, but rules are for prevention. So let's look at a real-world example. We've got a payment service that's throwing timeout errors, but because the error shows up in slightly different ways depending on the situation, Sentry's default logic went wild and created 47 separate active issues. 47 for what's probably one single underlying database problem. So an engineer comes in and writes this one beautiful, elegant fingerprinting rule. It just uses a simple wildcard pattern to say, hey, if the error message contains the phrase timeout waiting for connection, I want you to assign it this one fingerprint. And look at the result. It is just so satisfying. Those 47 noisy issues are immediately collapsed down to just 6. The noise is gone. The team can now instantly see the real scope of the problem and actually focus on fixing the bug instead of just clicking through a flooded inbox. That right there is the power of smart grouping. So I'll leave you with this thought. When you master these tools, you transform Sentry from a source of anxiety into a source of clear, actionable insight. You get to stop firefighting and start preventing fires in the first place. And with a quiet, organized inbox, the only question left is, what are you going to build with all that time and focus you just got back?